All right, so just going through lesson 6, we're looking at scales and how they affect the area. Okay, and so this first part, students should have access to this online. You are going to get this little applet that allows you to increase or change the number of the certain shape. Okay, so what this first part is, we're looking at how the area changes as we change the scale. So this first one with the blue block, it says where each side is twice as long. So if we want to make each side twice as long, so there we've added one block, but if you notice, we only have changed the side or doubled the side on one side. Once we've added 4, now we've actually increased both in height and width. What you'll notice is if the area of the original was one of these blue rhombuses, now that has increased by 4. Okay, the B part, it says now what about if we increase each side by 3? So there, the bottom is now 3. And now the side is also changed by 3. Because when we take a scale copy and we increase the dimensions by a factor, we're multiplying the original size by that factor. So here now it's a 3 by 3. And what you'll notice is that this has increased by 9. So the original area, now there is 9 of them when we only increase the scale factor by 3. Oops. And then the last one, 4. There we've both increased the length and the height, and you'll see there's 16. Okay, it asks you to do the same with each shape. So we'll go real quick. Okay, once again, it increased by 4, the area did, when we increased each side by 2. And once again, now we have 9 when we increased by 3. And you'll find the same thing with 4. Likewise with the red one, there's 4, every side is now 2 times bigger, and you notice the area changed by 4. Okay, so here it says make a prediction. How many blocks would it take to build a scale copy of these shapes using a scale factor of 5? Well, the pattern that I'm seeing is that for every scale factor, you're going to square it, so multiply that scale factor by itself, and then multiply the surface area. So each one of these represents 1. So when the scale factor was 2 on this red one, we take 2 times 2, which is 4. 4 times 1, which was the original area, one of those shapes. Excuse me. So we multiply that by the scale squared, and that's what we get for our area. So if we do the same thing with 5, 5 times 5 is going to give us 25. 25 times 1 is going to be 25. And real quick, if we go through this, there's 4 times bigger. This would be 5 times bigger. And if you count those all up, you will see that, in fact, it was 25 that it took to make this every side 5 times bigger. Okay, so that is the part that we want you to see, is that for the scale factor, oops. So the scale factor affects the area by the scale factor squared. All right, so when the original area was equal to 1, with a scale equal to 2, our new area, then area equaled, let me write this a different way. So scale 1, 2, 3, area. So when the scale was 1, our area was 1. When the scale was 2, it was 4. And when the scale was 3, it was 9. So we're taking the original area here times our scale squared to get our new area. And that works for each one. 1 times 3 squared equals 9, and so on. Right? So that's what we're looking at here. This next one is kind of building on this. But now, if you notice, when we start this one, we have 3 of the original area shapes. So, right, 3 of those rhombuses, so it'd be 3 times the original area. Now, this next one, that's what we're going to be working on. So, it shows a scale factor of 2. We're just going to take this, rotate it, and then put it in, whoops. Put it in place. And as we do that, what you'll see is that the area of the original, which was 3, it's now going to take 4 for each one. Okay, so if you keep filling this out, it's 4 for each one, so 4 times 3 is 12. Okay, so now on this one, our original, when our scale factor was 1, our area was 3 because we had 3 of those units. So we're going to do the same steps. So when it's 2, it's going to be 3, which is our original area, times 2 squared equals 12. So then if we take a scale factor of 3, it's going to be 3 times 3 squared, which is 9 times 3, which is 27. Okay, so this is the pattern that you should keep seeing, and this is how we are going to, or how the the area of a object or a figure is affected by the change in scale. Okay, so you can go through and answer these questions. You can spend time. You only have to do one of them. You're going to see that it all is the same, with the exception of your area here on the red one is going to be 2 rather than 3. So your original is 2, so 2 times 2 squared, 2 times 3 squared, 2 times 4 squared, and so on. And likewise with the green one, your area is now 4 at the beginning. And so you're going to just continue, or your original is 4, and that's what you're going to multiply by. Okay, you should be able to answer these questions now and make the predictions. So you're just going to take 4 squared and times that by the original. So on the blue one, it's going to be 4 squared times 3, so 16 times 3. Or it would be 5 squared, which is 25, 25 times 3. Or 6 squared is 36, 36 times 3, and so on to get your new dimension. And so how the patterns here are kind of similar to the original and different. They're similar because you increased by 4, or you doubled the scale size, but they were different because the starting amount was different. So here your starting area was 3 of these shapes instead of 1. Okay. So now let's go down to 6.3. This, are you ready for some more? We didn't cover that in class. I'm not going to go over that. It kind of shows the same thing, that you're going to have that same scale factor. So right here, we want to fill this out. And it's going to be one of 2 factors. One of 2 figures. So the 2 figures is a parallelogram with a height of 2 and the base 5. The other is a triangle with the base of 4, height of 5. Okay, so this is the original. So to find our area, it's base times height. On a parallelogram, it's the same as a triangle, because if we were to cut this off right here and then bring it to the other side, we would have a perfect rectangle that's 5 by 2. So area of this for a scale of 1 is going to be 5 times 2, which is 10. Okay, so now if we do a scale of 2, this becomes 10 times 4, because everything's doubled, right? Which equals 40. A scale of 3, everything's going to increase, right, by 3. So 5 times 3 is 15. 3 times 2 is 6. 15 times 6 is 90. Okay, and what you're going to see is that this follows that same pattern. 10 times 2 squared equals 40. 10 times 3 squared equals 90. So then when we get to the 1/2, so we can do it this way, where 1/2 of 5 is 2.5, 1/2 of 2 is 1. When you multiply those together, you get 2.5. Likewise, 10 times 1/2 squared is equal to 2.5. Because 1/2 squared is just 1/2 times 1/2, which equals 1/4. And then 1/4 times 10 equals 10 divided by 4, which equals 2.5. Okay, and the same thing is going to apply for, I believe it's the 3/5. Now you're just multiplying 10 by 3 squared, or 3 times 3, which is 9. 5 times 5, which is 25. That'd be 90 divided by 25. And then you get your answer, which 5 goes into both of those, so that would be 18. Okay. All right, and that's what what I wanted to show with these ones. So no matter the shape, whatever the starting area is, you're going to increase it by the scale factor squared. Okay, same goes for the triangle, except area of a triangle is equal to base times height times 1/2. So 4 times 5 is 20. Half of 20 is 10. So this would be 20 times 1/2. And you'll find that this one is going to increase the same as this one with those scale factors. So that would be filling out this chart right here. Oh, sorry, it was 1/3. So instead of that 18, it would have been 1/9 times 10. All right. So that's what you should see, is that as you do both figures, the area is changing once again by that scale squared. Okay, and then this last part, it just wants you to find what the area would be if it was 5 times. So 5 times 5 is 25. 25 times 10 is 250. So the area here would be 250. And this is that 3/5 that I was thinking of. So we did that. That 10 times 3/5 becomes 18/5. Okay. So that was it. That's lesson 6. Just wanted to recap once again. The area of a figure of shape increases by the scale factor squared. And that's what this just kind of ties in right here. Just review. So go ahead and double check that with your answers and your notes. And if you have any questions, just feel free to reach out.